Question 8. So, surface area. Remember what this comprises. Just imagine you're wrapping this up in wrapping paper. What's the minimum amount of wrapping paper you'd need to exactly cover all faces of the shape? So I suggest you just break it down into the net, really, into each of the faces. So we've got 2 of the triangles on the end. So those dimensions are 8 by 6. We've got this slanty rectangle here, which is 10 by 9. We've got the back of it here, which is 8 by 9. And we've got the base, which is 6 by 9. So working out areas of triangles, it's half times base times height. So those are a couple of 24s. Areas of rectangles is just base times height. So in 90, 72 and 54. Add up these 5 bits of wrapping paper and we get 264 centimeters squared. It is area, centimeters squared. Question 9. So again, we're wrapping up the cylinder. So what does it comprise? Well, it comprises a couple of circles, top and bottom, and then this slanty bit, which when you unwrap the slanty bit, you get a rectangle. So working out the area of each of these, well, the circles are easy enough. An area of a circle is pi r squared. The radius is 6. So pi times 6 times 6, pi r squared, gives us the areas of the 2 circles at 113.04 each. Now this curvy surface, which when unwrapped being a rectangle, is a bit more tricky. The height's okay. I think it's pretty obvious that that length of the rectangle is 18, but you've got to realise that as you unfold this curvy bit, the actual length of it is going to be the circumference of the circle. So pi times d, so pi times 12. So that length there is the circumference of the circle, which is pi times 12, 37.68. We said the height was 18, so to work out the area of a rectangle, base times height, so 37.68 times 18, giving us 678.24. The total amount of wrapping paper needed, so add the 2 circles and the rectangle together, giving us this, which is 904 to 3 sig figs. Question 10. Okay, we're given the surface area of the curved surface area of a cone is pi rl, but L is the diagonal, the slanty height. So on this occasion, this slanty height is not given. So like earlier on, we're going to need to use Pythagoras. We know that the height straight up is 12. We know that the radius is 5, so using Pythagoras, L squared equals 5 squared plus 12 squared, so L squared is 169, square root of 169 is 13, so this slanty height is 13. So using the formula pi rl, we've just got pi times the radius, which is 5, times the slanty height, which is 13, which is 65 pi. Now we've been asked to give your answer as a multiple of pi, so 65 lots of pi is how they want the answer.